Hello, in this class I am going to talk about systems surrounding thermodynamic equilibrium, thermodynamic properties and SI units, basic units. This is the volume 2 of Introduction Thermodynamics. System. A thermodynamic system is a certain quantity of matter which is bounded by a boundary. We introduce boundaries in our study called the system and surroundings. The boundaries are set up in a way most conducive to understanding the energetics of what we are studying. Defining the system and surrounding is arbitrary, but it becomes important when we consider the exchange of energy between the system and surroundings. Two types of exchange can occur between system and surroundings. Energy exchange, that is in the form of heat, work, friction, radiation, etc., and matter exchange, in the form of movement of molecules across the boundary of the system and surroundings. Based on the types of exchange which take place or don't take place, we will define three types of system. First one is the isolated system. An isolated system is a system in which no exchange of matter or energy occurs. We can see in this diagram that it is the system which is not exchanging any energy or matter. It is surrounded by its surrounding, but it is not exchanging any energy or matter. Next we have an open system. In an open system, exchange of both matter and energy occurs. We can see in this system there is an exchange of energy, that is energy in and energy out, and there is an exchange of mass in and mass out. It is also surrounded by a boundary. Open system is also called as a controlled volume system. Controlled volume is defined as a volume which encloses the matter and the device inside a controlled surface. Everything external to control volume is the surroundings with the separation given by the control surface. The surface may be open or closed to mass flows, and it may have flows from energy in terms of heat transfer and work transfer across it. The boundaries may be movable or stationary. Next we have closed system. In a closed system, there is no exchange of matter but some exchange of energy occurs. We can see in the diagram that the system is bounded by a boundary. There is an exchange of energy, that is energy in and energy out, but there is no matter, there is no mass transfer. Closed system is also called as a controlled mass system. In the case of control surface that is closed to the mass flow, so that no mass can enter or escape the control volume. It is called a controlled mass containing the same amount of matter at all times. Next we have thermodynamic properties. In thermodynamics, a property is any characteristic of a system that is associated with the energy and can be quantitatively evaluated. The property of a system should have a definite value when the system is in a particular state. Thermodynamic property is a point function. Properties like control, properties like volume of a system that depend on the mass of a system are called extensive property. Properties like pressure or temperature which do not depend on the mass of system are called intensive properties. The ratio of extensive properties to the mass of the system are called specific properties, and therefore some become intensive properties. Substance can be found in three states of physical aggregation, namely solid, liquid and vapor, which are called its phases. If the system consists of a mixture of different phases, the phases are separated from each other by phase boundary. The thermodynamic properties change abruptly at the phase boundary, even though the intensive properties like temperature and pressure are identical. Next we have thermodynamic equilibrium. When the property of a system is defined, it is understood that the system is in equilibrium. If a system is in thermal equilibrium, the temperature will remain same throughout the system. If a system is in mechanical equilibrium, there is no tendency for pressure to change in a single phase system if the concentration is uniform. And there is no tendency for mass transfer or diffusion. The system is said to be in chemical equilibrium. A system which is simultaneously in thermal, mechanical and chemical equilibrium is said to be in thermodynamic equilibrium. Sorry, there is certain mistake. There must be thermodynamic equilibrium. Next we have thermodynamic process. A process is path followed by a system in reaching a given final state of equilibrium state, starting from a specified initial state. An actual process occurs only when the equilibrium state does not exist. An ideal process can be defined in which the deviation from thermodynamic equilibrium is infinitesimally small. All the states the system passes through during a quasi-equilibrium process may be considered equilibrium states. For non-equilibrium processes, we are limited to a description of the system before the processes occur and after the equilibrium is restored. Several processes are described by the fact that one property remains constant. The prefix iso is used to describe such processes. A process is said to be reversible if both the system and its surroundings can be restored to their respective initial state by reversing the direction of the process. A reversible process. If the process happens slow enough to be reversed, is a reversible process, and an irreversible process if the process cannot be reversed, like most of the processes are irreversible. An isobaric process. The processes which are done at constant pressure are isobaric processes. Isochoric process. The processes which are done at constant volume condition, those are called isochoric process. Isothermal process. The process done at constant temperature are termed as isothermal process. Then we have adiabatic process. The process where we have Q is equal to 0, that is, there is no heat interaction. The process in which there is no heat interaction are called as adiabatic process. Next we have cyclic process. The process where the initial state is equal to the final state are cyclic process. Next we are having the basic units, that is our SI units. The SI unit of mass is kg, mole. The mole is the amount of substance that contains as many atoms as there are atoms in 0.012 kg of carbon. SI unit of length is meter, time is second. SI unit of temperature is Kelvin. The Kelvin is defined as the fraction of 1/273.16 of the thermodynamic temperature of the triple point of water. The relation between Kelvin and Celsius temperature is K is equal to C plus 273.15. The triple point of water is at 0.01 degrees centigrade. Derived units. Force 1 unit is equal to derived unit. Force 1 Newton is equal to 1 kg meter per second. Pressure of 1 Pascal is equal to 1 Newton per meter square. 1 bar is equal to 10 Pascal and 1 atmosphere is equal to 101,325 Pascal. In thermodynamics, we are concerned with the absolute pressure. Gauge pressure is equal to absolute pressure minus atmospheric pressure. Ordinary vacuum gauge pressure is equal to atmospheric pressure minus absolute pressure. Thank you. This was our This is our volume 2 for introduction of thermodynamics. This is the end of the topic.